friends. Today we are just doing the application of the nested loop. So I've taken the example of a prime number. So what the first programs actually actually does, that is to print the numbers from 1 to 100. First of all, we have taken, that's why what has been quite rightly taken, that's 1 to 101, because we know that the range function always stops 1 before. Okay, so it will take from 1 to 100. Now 1 cannot be a prime number. Okay, so 1 has been excluded, and we had started because we know that any prime number has two factors. Okay, am I right? Any prime numbers has two factors. What, say 7 is a prime number, then 7 is having only two factors, 1 and the number itself. Sorry, 1 and the number itself. Now any number, suppose I have entered, any other factor has been found which is other than 1 and the number itself, then it cannot be a prime number. It is a composite number. All right, say for example 15. 15 is having, because for all the numbers two factors are in common, 1 and the number itself, and apart from that 15 is having one more factor, 3 and the 5, because 3 and 5 exactly divides 15. So 3 and 5, so in this case factor count is 4. Now it cannot be a prime number. Prime number will be a number which will have only two factors, and the same logic that we have incorporated out here. All right, so now you see how it has been found. So when one number has been picked up from the outer loop and it has been put into the inner loop, and in the inner loop we are going from range 2 to n minus 1. Suppose if we are checking for 5, then we are going up to where? 2 to 4. Okay, then 2 to 5 minus 1 is 4. Suppose you are checking 7, then what will happen? N minus 1 is 7 minus 1 is 6. That means 2, 3, 4, 5. These 5 things we are checking. Okay, because suppose 7 is the number immediate before whatever is there, that cannot be divide itself exactly. Okay, that is impossible. Okay, that is why we are, every time we are checking the number out here, every time we are checking the number out here with the updated value of 5, and if found, then count will increase. So if the count is increasing, at least one factor has been found in that case, and then and there the loop will be broken, inner loop will be broken, and it will come out straight under the if block. And how the if block is printing? If block will print in this position when the count will be 0 and n is not equals to 1. Only these two conditions to be satisfied, then only the particular number will be printed. Now say, yeah, say you are checking for 6. Okay, then what will happen? 2 to 6 minus 1 is 5, but 2, 3, 4 will be dividing 6. Now if 6 is there, then 6 divisible by 2, it is true. Then it is exactly divide 6. Then what is happening? The condition is becoming true, count will increase, and the particular innermost loop will take a break and work out over here. So when 2 is exactly divided 6, then count has already changed. So when it will jump out of this particular inner loop and it will come over here, it is saying that count is already having the value 1. So 1 is not equals to 0. Okay, 1 equals to 0 is becoming false. Okay, and what will happen? The number will not be printed since it is not a prime number. Now say for example 5, what is happening? Suppose for 5, then it will keep on divide up to 4, 2, 3, 4. 5 will be divided by 2, 3, 4. None of the cases it is exactly divisible, so count will not increase, count will remain as it is 0, and it will come over here, then it will see that yes, count is not count is equals to 0, which is true, and n is not equals to 1 also, that is also true. Then what is happening? The 5 will be printed as prime number, and each time this count has been modified to again reset to 0 in order to get a new value to be picked up. And if it is not updated or not be reset to 0, then what will happen? The previous value also will be taken into consideration, and you will have error in your program. You will not get the correct output. That is why each and every time count will be 0 as we take a new value. Understood? That is the thing. All right, so that you have to understand. Fine. Okay, that is the thing. Now we will go another program. We will see this is the program actually that prints the program prime numbers from 1 to 100. All right, now the same prime number we are discussing with different programs, but the style will be different. So till now, what we have done here, okay, that is 1 to 100, and two more programs are there. That is also by using the nested loop concept only, but here we have used the while loop construct. Okay, so if we are executing this program, the output will be coming in this way. Okay, watch it, the output out here. Okay, yes, that is the output of this particular program, which is this. This is start from 2 to, that is 1 to 100, from 2 to it is start printing out here. Once more, I'm just executing this program. Okay, now we watch it carefully. This is the one that 2, 3, 5, 7, and up to 100 it has been printed. Okay, the last program that we had discussed with you, that is also the same thing, but there we have used the using the prime number up to 100 by using the for loop construct. Okay, this is the same program. Side by side, I am keeping both these programs, so then you can see I'm executing this program. That is similar logic, only the construct is bit different in both cases. Here also the same thing we had got, and here if you run, you will also get the same thing. All right, so no difference at all. So that is the thing. So here what is the thing, here the for index, and here straight away you can, it is very easy to understand from here. Okay, one less than or equals to 100, same thing, count equals to 0, we are starting from 2, means we are excluding two factors, 1 and the number itself, and apart from that, if any number is found, any factor has been found, then that cannot be a prime number. All right, so each time the I value is updated and it is checking in this innermost loop, and once one is breaking or the loop is out of this one, then what is coming, the n has been increased because n is getting ready for the next number. Okay, then it has been checked over here. If true, count is becoming again 0. Okay, because the otherwise the previous value will get added. That's why we cannot keep the count as have to keep the count as 0. All right, that's the thing will happen, and it will start with I equals to 2. 2 means we are excluding 1. We are starting from 2 and we are leaving up to n, means less than n, means just before n we are stopping. All right, because we are not including the n. Okay, because in that case what will happen, our program length, time of execution will be less. Okay, so two factors we are just excluding in that way, and apart from that, anything else is, any other factors have been found, count will increase its value and it will take a break. And what will happen, once it takes the break, it will come out and it will check, count 1 at least is not equals to 0, is false. Okay, and property says that both the condition must be individually true, then only the next, then only the it will be printed, otherwise it will not be printed. All right, that is the thing. So when count is becoming 1, so one condition is becoming false, so no question of printing a non-prime number. Okay, simple. Here also the same thing. Here instead of this particular relational operator, we have used the range function only. That much is the difference. Otherwise, both the programs are same. These are the applications of the nested loop. Okay, they're using while as well as using for loop. Okay, and the last one is the same thing only, but here a bit manipulated in this way. That is up to a range. Okay, suppose if you want to find the prime number within a range, okay, that is there. Okay, so a minimum value to be entered, say for example within 30 to 50, what are the prime numbers, I want to see 30 and then 50 I'm giving. Same logic has been used, same logic, I did not change anything over here. Same range function has been used out here, and in the similar way it is functioning. We are excluding the two numbers, two factors, one and the number itself, and count is resetting for while checking a new number. So it is just checking why n plus 1 has been given, because we know that range stops at 1 less. Okay, so we are giving 50, it will stop at 49, so 50 won't be checked. That's why 50 has been increased to 51, so it will check from 30 to 50. So I'm pressing enter, you see these are the 5 prime numbers has been found within that range, and the same thing has been printed out here. Okay, so all three programs you have seen, same logic has been incorporated, but constructs are different. Okay, and try to do these things, implement practically, so you will get more flair on programming. Understand? Okay, then do the practical nicely, and we will join in the next class. Thank you. Now the same prime number we are discussing with different programs, but the style will be different. So till now, what we have done here, okay, that is 1 to 100, and two more programs are there. That is also by using the nested loop concept only, but here we have used the while loop construct. Okay, so if we are executing this program, the output will be coming in this way. Okay, watch it, the output out here. Okay, yes, that is the output of this particular program, which is this start from 2 to, that is 1 to 100, from 2 to it is start printing out here. Once more, I'm just executing this program. Okay, now we watch it carefully. This is the one that 2 3 5 7 and up to 100 it has been printed. Okay, the last program that we had discussed with you, that is also the same thing, but there we have used the using the prime number up to 100 by using the for loop construct. Okay, this is the same program. Side by side I am keeping both these programs, so then you can see I'm executing this program. That is similar logic, only the construct is bit different in both cases. Here also the same thing we had got, and here if you run, you will also get the same thing. All right, so no difference at all. So that is the thing. So here what is the thing, here the for in range, and here straight away you can, it is very easy to understand from here. Okay, 1 less than or equals to 100, same thing, count equals to 0, we are starting from 2, means we are excluding two factors, 1 and the number itself, and apart from that, if any number is found, any factor has been found, then that cannot be a prime number. All right, so each time the I value is updated and it is checking in this innermost loop, and once one is breaking or the loop is out of this one, then what is coming, the n has been increased because n is getting ready for the next number. Okay, then it has been checked over here, if true, count is becoming again 0. Okay, because the otherwise the previous value will get added. That's why we cannot keep the count as have to keep the count as 0. All right, that's the thing will happen, and it will start with I equals to 2. 2 means we are excluding 1. We are starting from 2 and we are leaving up to n, means less than n, means just before n we are stopping. All right, because we are not including the n. Okay, because in that case what will happen, our program length, time of execution will be less. Okay, so two factors we are just excluding in that way, and apart from that, anything else is, any other factors have been found, count will increase its value and it will take a break. And what will happen, once it takes the break, it will come out and it will check, count 1 at least is not equals to 0, is false. Okay, and property says that both the condition must be individually true, then only the next, then only the it will be printed, otherwise it will not be printed. All right, that is the thing. So when count is becoming 1, so one condition is becoming false, so no question of printing a non-prime number. Okay, simple. Here also the same thing. Here instead of this particular relational operator, we have used the range function. Only that much is the difference. Otherwise, both the programs are same. These are the applications of the nested loop. Okay, they're using while as well as using for loop. Okay, and the last one is the same thing only, but here a bit manipulated in this way. That is up to a range. Okay, suppose if you want to find the prime number within a range, okay, that is there. Okay, so a minimum value to be entered, say for example within 30 to 50, what are the prime numbers, I want to see 30 and then 50 I'm giving. Same logic has been used, same logic, I did not change anything over here. Same range function has been used out here, and in the similar way it is functioning. We are excluding the two numbers, two factors, one and the number itself, and count is resetting while checking a new number. So it is just checking why n plus 1 has been given, because we know that range stops at 1 less. Okay, so we are giving 50, it will stop at 49, so 50 won't be checked. That's why 50 has been increased to 51, so it will check from 30 to 50. So I'm pressing enter, you see these are the 5 prime numbers has been found within that range, and the same thing has been printed out here. Okay, so all three programs you have seen, same logic has been incorporated, but constructs are different. Okay, and try to do these things, implement practically, so you will get more flair on programming. Understand? Okay, then do the practical nicely, and we will join in the next class. Thank you.